Hello and welcome everybody. My name is Jonas Pilz. I'm Master Trainer at Maxon, and today I want to show you how you can create some stunning Cyberpunk titles using Cinema 4D and After Effects, and we're going to use Redshift as the renderer. So here is what we are going to create. Let me play back the animation here. So what you can see is some cubes with displacement on them, some emissive materials, we see a street material and some fog and so on, and we are going to create all of that. So we're going to start by creating those cubes with the displacement textures in Redshift. Then we're going to animate these cubes using MoGraph. Then we're going to create the street material and set up some lighting. And we're also going to create that fog that you can see in the background. And in the end, we are going to set up some AOVs and light groups, so we have maximum control over each of the lights in compositing. And of course we are going to render this out then, and we're going to use the ACES CG color space to render it out. And also I want to show you how you can then use ACES in compositing in After Effects to finish your compositing. And one last thing before we jump into Cinema 4D is that all of the textures that we're going to use are available for free in Cinema 4D's asset browser. So now let me jump into Cinema 4D. Here we are, and the first thing I want to do, because we want to use Redshift as the renderer, is I'm going to go to the render settings, and in here I'm going to set the renderer to Redshift. All right, now I'm going to close this and I'm going to create a cube. So the cube is going to be 20 by 20 by 20. And for the displacement, I'm also going to increase the segment count to 20 by 20 by 20, so that we get a cube that is like this one. So what I just did via shortcut is going to display and activating the grow shading with lines. We can go back to grow shading here for now. I just wanted to show you the subdivision. All right, so the next thing I want to do is I want to open up the material manager and create a Redshift material and assign it to the cube. And I'm also going to rename it to cube 1. And I'm also going to rename the cube here to cube 1. And then I will add a Redshift light, which is going to be a dome light. So here we've got a dome light, and now everything is black. So what I'm going to do now is I'm going to change the display to quick shading, because this will show me the objects in the viewport without any lighting. Cool. And now I can go to Redshift, start IPR, and here we are. Now that's Redshift rendering. And as I told you, the first thing we want to do is we want to add the displacement here. So let me open up the asset browser and search for a greeble map. And as you can see here, there are quite a few greeble maps. Let me reduce this to just the media. And I want to use this in my material. So let me bring up the material manager again, and I'm going to double click this one. And let me set this up so that we use this part of the screen. So that's great. Cool. The first thing I want to do, as I said, is using this texture here in the Redshift shader graph, and I'm going to directly output it so that we can see what we are doing. I also want to just get rid of the asset browser, and I'm going to switch to 4 views here and make this a little bit wider so that we get the maximum available space up here. All right, using this texture, we can make everything look much more interesting. We want to use that in the displacement, and the way how we can do that is in 2 steps. First of all, we need to assign it here as displacement, and then we also need to tell the object that we are going to use displacement here. So let me search for displacement in the Redshift nodes, and I'm going to add the displacement node and connect the output of the texture node to the text map input. And then I'm going to throw this into the output node under displacement. So this should already work now. I'm going to connect the Redshift material to the surface. And as you can see, it doesn't because we didn't set the cube up yet. To set the cube up, we right click it and then we go to Redshift tags, Redshift object tag. And now it's the first time that I have to get rid of the shader graph here. And what I want to do here in the Redshift tag is I want to go to the geometry tab, and then I'm going to override the geometry. I'm going to enable tessellation, but I don't want it to be screen space adaptive, and I also don't want it to be smooth, but I want it to be displaced. So let me check displacement, and now we can already see that it is displaced. Cool. So the next thing I'm going to do is I'm going to decrease the minimum edge length to 0.5 to get a little bit more detail. And now let's say I'm happy with it. And well, maybe let me increase it a little bit more by upping the maximum displacement and the displacement scale. So here we go. Now it's a little bit more extreme and you can see what's going on. Cool. Now let's have a look at the material again because we want to adjust it. So what I want to do here is I want to make these areas here, those little things, be emissive, and also some parts here I want them to be emissive so that it's looking a bit more interesting. All right, I'm going to use this texture for that as well. So let me pipe that into the surface again just to see that texture. And then I'm going to use a ramp to define these areas. All right, let me search for the ramp and throw it into my shader graph. And then I'm going to connect the out color to the input. And I'm going to use that here in the surface output. Right, now we can use this gradient to remap this texture. So let me bring this back to white and this to black, and maybe we can bring them closer together so that we get these guys here white, and we're pretty close. And then I'm going to copy this knot over there, and that's already a good start. Now we can select all of them and just move them around a little bit. Maybe they can be narrower together. Something like this is what I like. And then I also want these areas here to pop out. So I'm going to create another copy of these three here by holding down the control key and just dragging them to the side. And as you can see, everything is updating in real time. And this is what I want. Yeah, that's looking great. Cool. So now we've got a few areas that are white or gray. And now I want to remap them again to colors. So let me create another ramp and add it to this ramp here, and then have a look directly at it. All right, so now what I want to do is I want to bring this white knot in, and I'm going to make this some sort of pinkish. Hit OK, and now you can see everything is pink. And now the second one, I'm gonna make it blue, like so. That's looking good. Let me bring this in a little bit more. And I think that's pretty good. All right, now that we remap this displacement map, I want to use that in the emission. So let me pipe this into the RS material node under overall emission color, and then pipe the color output into the surface input of the output node. Cool, now you can see nothing because in the RS material node we have to go to overall and to bring up the emission weight. We can go with 1, this will bring up the emission here. We can also bring this up to 2, then it will be a little bit brighter. Yeah, I'm gonna go with 2 for now. And in the RS material under base properties, I'm also going to bring down the color a little bit, like so. And also I want to increase the reflection roughness a bit. So let's go to something like 0.3. And now I'm happy with that. All right, I just saved this, and now I'm going to create a few copies of that cube, like so, and also 2 copies of that material, because we want to create some variation. So this is going to be cube 1.2, and we are also going to assign those materials according to the names. All right, and what I want to do here is first I want to adjust the displacement map here of that material. So let me bring up the asset browser again, and let me use another displacement map. In this case, I'm going to use this one here. So let's make sure this node is selected, and here is the file path, and I'm just going to drag and drop this one in here. And now you can see that we've got a second one, but they are on top of each other. So maybe first, let me zoom out a little bit and let me place those cubes next to each other, like so. All right, so this one is looking good already. Now let's have a look at what we can do in this material here. I'm going to bring up the asset browser again, and in this case, let's say we are going to use this texture. So let me select the texture node and drag and drop this texture from the asset browser into the file path, and now we've got this. Cool. Now we can fold away the asset browser and set those materials up a little bit more. So in this case, I definitely want other areas to be emissive. So let me jump into the ramp, and let's just play a little bit with these knots here and drag them over to other areas. I pretty much like this one here, like so. And I'm also going to play with this one here. Let's have a look. Oh yeah, I like this. Okay, now our cubes are finished and we can start creating the actual title. And in order to do that, I'm going to deactivate the Redshift viewport IPR. I'm also going to get rid of the Redshift shader graph, make the viewport full screen, and fold away the material manager. And what I want to do next is I want to throw all of these cubes into a cloner. So I create a cloner and throw them in. I'm going to call this one H. And now I'm going to set up the cloner so that the clones are going to be random. Also that I'm going to create multi-instances because this is better for the performance. And then I'm going to adjust the count from this to 5 and from 3 to 1 here in the Z. And then I'm going to bring them closer together like so. And what I also want is I want all of these clones to be rotated by 45 degrees. So let's go to the transform tab here and let's play with the values. Perfect. Let's set this to 45. And here we go. So we're going to set this up to be like that. That's actually looking pretty good. And now I'm going to place this guy somewhere around here. Cool. Now we can add a copy of this one simply by holding down Control while dragging to something like that. And let's also move both of them a little bit to the side like so. And then we're just going to Control, click and drag to create the other ones like so. Cool. So this is supposed to be my H. This is supposed to be O. This one, we have to swap them. So this one has to be P and this one E. All right, that's looking good already. Now let's actually create those letters. And I'm going to do that by creating MoGraph selections and then hide them using an effector. And this can be done by selecting all of these cloners. And then I go to MoGraph selection, and I'm going to select all of the clones that I don't want to see. So I start with the H. I don't want to see these two, and I don't want to see these two. In the O, I don't want to see these three. Here in the P, I don't want to see these two and these four. And here on the E, I don't want to see these two and these two. And now with those clones selected, I go to MoGraph again and hide selected. So now you can see that we already have our title, which is looking pretty great. Cool, now let's animate this so that we get a transition from cubes appearing from the left to the right. They should be scaling up and also rotating a bit. So what I do is I create a plane effector with these 4 cloners selected. And well, as you can see, nothing happened because I accidentally still had these MoGraph selection tags selected as well. So what I have to do is here in the effector tab, I just throw out the MoGraph selection tag out of the selection field. And now this plane effector has got an effect on the clones. So in the parameters tab, I'm going to deactivate position, and instead I'm going to activate rotation. Let me play with the heading here. That's the correct one. I'm going to set this to 180. And then in the scale, I'm going to set this to uniform scale and bring it down to -1. So now everything is gone and we need to bring it back by using a field. So in the fields tab, I'm going to create a linear field, and now you can see that some of the clones are back. So the linear field is actually creating a gradient in 3D space. And what I want to do next is I want to make this a little bit smaller. And I also want to rotate it so that it's like this. And now we want to animate this guy from the left to the right. And I'm going to switch to the move tool and to world mode, and then move it to the very left. And in the linear field, I go to coordinates and set a keyframe for position X. And then I go to, let's say, frame 60, move it over to the right and set another keyframe for position X. So now you can see that the animation is not linear. So it's smooth, starting slowly, becoming faster and slowing down again. In order to avoid that, I right-click the parameter, go to Animation, Show F-Curve, and bring it up a little bit. And if you have the correct track selected here, but you don't see anything in here because the range is way off here at the moment, you can simply press the letter H and this will frame the selected curve. So now I can just select the 2 keyframes and set them to linear. All right, now I can get rid of the timeline again. Let's have a look at the animation. That's looking great. All right, I want to have it like that. And I'm also going to make the linear field invisible. And now we can start creating the street and lighting the scene. So let me pause the animation and maybe go back to frame 60. And then I'm going to create a plane and scale it up a little bit. This is going to be my ground. Now we can also have a look at this from the side a little bit and move it to the back so that we just have a little bit of ground here in the front, but a lot in the back. And then I'm also going to bring up the material manager again and create a new Redshift material and assign it to the plane. This is going to be my street material and also my street object. Cool. Now let me fold this away, go to 4 views, bring this into the center again a little bit, and go to Redshift Start IPR so that we can see what we are doing. All right, this is looking pretty great. I'm going to delete the dome light. We're not going to use that anymore. And instead, I want to add an area light. And I'm going to make this area light a lot slimmer and wider. And I'm also going to move it up and rotate it so that it's looking to the front. And what I want to do here with the area light selected, I go to Object and scroll down and make it visible. So now that we can see where it is here and also where it is in the reflection, because I want to sync these. So let's set the size Y to 5 and let's bring up the size X to something bigger, like so. All right, now actually that position is pretty good, but what I want to do is I want to bring this light down a little bit but the reflection is supposed to be still here. So that's looking good. That's my background 1 light. And I'm gonna create a copy of this one and call it background 2. And now I'm gonna move it to the back like so. Yeah, I want this reflection to be here, but I want the light itself to be a little bit lower. So that's looking great. And now let me colorize the lights. So I want to colorize this one to be a little bit bluish and the front one to be a little bit more greenish, like so. So that's looking good already. And next I want to create the area lights to light those cubes from the front or from the sides. So let me create a new Redshift light, area light. And let's bring this one over. I'm going to use the 4 views for that to this place. And let's also going to rotate it to something like that. Maybe we can even use a steeper angle like this one. And I'm going to call that right because it's coming from the right. And then I'm going to control drag here to create a second light, move that over to the left and a little bit more like frontal. And then I'm going to move that one up as well to something like this. All right, now in order to better identify where which light is coming from, I'm also going to, first of all, rename this one and then set up some colors. So for this light, I want the color to be blue. And for this light, I want the color to be, let's say, pink. All right, let me make this full frame so we can have another look at it. And I'm pretty happy with this. So the next step I'm going to do is I want to set up the street material. Cool, so I'm gonna make this smaller again, bring up the object manager and the shader graph. And then let's play with the street material. And this is gonna be quite exciting. So the first thing I wanna do is in the RS material node, I'm going to bring down the color because we want this to look quite cool, but we wanna use the reflection roughness and reflection weight for that. So the next thing I wanna do here is I want to open up the asset browser and search for grunge because there is a cool map here that is a grunge map. So let me bring this into the shader graph and let me fold away the asset browser again and pipe this guy directly into the surface out so we can see what we are doing. So what you see here is that we have this grunge map with a few cracks in it, and this is very interesting. So let me go down to the scale, and this is actually a tile parameter. So if we bring it up, we will scale the texture down, and that's a good size. I also want to offset it to something like this. I think this is quite interesting. Because now we want to use the very same technique that we used before with the cubes materials, where we used ramps to remap this, to create our roughness map out of this, as well as our reflection weight map. So let me create a ramp. And let's pipe the texture into the ramp and the out color into the surface. And now again, we can use this ramp to remap this whole thing. So what I want is I want these dark areas to be not too rough. We are going to create the roughness map first. Maybe let me pipe this into reflection roughness so that we know what we are dealing with. All right, so we want black areas here, or at least dark gray areas here that are pretty plain so that we can use that as water. And then I'm going to set another knot here and bring this very close. And this way we can create a pretty harsh rim here, maybe a little bit less. Or let's move this a little bit to the side, like so. And yeah, I'm pretty happy with this. Now let's have a look at the color values, because we're going to control the roughness with this. I never want to have something that is 0% rough. So let me bring this up to something like 5. And here I want to use a value of, around 50 is good. And this one is at around 100. Maybe that's also good for now. Okay, and now let's create the weight map, the reflection weight map. I'm just going to create a copy of this one, pipe the out color of the texture in here, and pipe this one into the reflection weight. And also we want to output this directly so that we can see it here. And we want to leave the knot positions here. We just want to recolorize them. Now this is going to be the weight map. So in these areas where we have glossy water, we want to have full reflectivity. And then here I'm going to go to something like 70. And here I think we can work with something like 30. Let's have a look at the map. Yeah, this is looking fantastic. And now let's try to use the out color here in the surface, and then we can see what our map is going to look like. And you can see that this is already looking pretty good, because we have those areas that are very reflective, and we have these areas that are very glossy, and this is perfect. The last thing I want to add here is some bump, and I'm going to use the reflection weight map for that as well. So I'm going to search for bump and use the bump map node together with the weight map. So I'm going to draw a connection here and output this one to the overall bump input. And now some things have changed. We now have a bump, but we need to reduce it a lot. The height scale is set to 1. We need to go with something that is like 0.03 or something. All right, so that's looking much better already. And I think I'm happy with that. So let's directly move on to the next topic, which will be the fog here. In order to create that fog, I want to make those two lights invisible again. So I'm going to select the two and scroll down and untick visible. So now we cannot see them again, but they are visible in the reflections. And now let's create the fog. We need to create another object, which is a Redshift object, Redshift environment. And once we add this, you can see that everything will be blown out. And the reason for that is that every single light contributes to the volume scattering to that fog here by 100% by default. But if we go to every light's details tab, we see that there is the volume contribution parameter here. And if we bring that down to like 1%, which will be 0.01, then we start seeing something again. Now you can also see that the light that is coming from the right is pink, the one coming from the left is blue, and so on. Cool, but I want to create some clouds here. So I want to noise this environment, so to speak. I want to noise this fog, and I'm going to show you how you can do that. First of all, we need a new material. So I go to create in the material manager, Redshift, materials, material. And in here, what I'm going to do is I want to delete the RS material node. And instead, I'm just going to type in noise, and I'm going to use the Maxon noise and pipe that one into the output's volume input. And now with that applied, I'm going to rename the material to fog and apply that material to the Redshift environment. And now you can already see that we have some variation here in the fog. Now let's set it up a little bit. I'm going to change the type to Booyah. And also I want to scale this up, let's say to 15. And now, as you can see, with just a few clicks, we created a very atmospheric look here, and now we can already take care of the rendering. So let me close the Redshift shader graph and also make the viewport full size, and also fold away the material manager so that we can see what we have here. Cool, so this is looking really great already. In order to prepare it for compositing, I want every single light to be like a separate layer in compositing. And this is why I have to create some light groups and then output them as separate files. So let me show you how you can do this. First of all, I'm gonna stop the IPR and then I'm gonna use the Redshift render view, which is a little bit more capable than the viewport IPR. So here you can see quite a few buttons up here that allow you to adjust some things. If I make it a little bit bigger, you can see that there is even more. And here we have even some settings to apply some post effects and so on. And now let me set this up. So what we see here is all of the passes that we are going to render. And if I unfold this, you can see that we just have the beauty pass in here. If I want to add more passes, I have to create some AOVs. That's multi-passes in the Redshift context. AOV stands for arbitrary output variables. So let me pause the rendering here and let me bring up another new window, which is the Redshift AOV manager. And in here, we just need one pass, which is the beauty pass. And if we input that here and select it, maybe we should make this a little bit wider, you can see that we can define light groups. And those light groups have to be defined in the lights themselves. So let's start with the left light, and I'm going to show you where I can do that. You have to be in the Details tab, and then you can see the AOV light group drop down here. Right now we don't have any light groups. You can add a new light group either from here or from this drop down, new, and here we go. I'm going to call this left, hit OK. Then I'm going to select the right light, create a new light group, call it right, and I'm going to do the same for the others as well. So BG1 and BG2. And as I do that, you can see that these light groups are showing up here in the light groups section. Now, if I tick all light groups here and render again, we can see that in the dropdown, we now have all of the lights as separate passes. So let's have a look at the right one, at the left one, background 1. I really love this pass here. And background 2. All of them are looking great. And if we compose them together, we should get like the final image. But we need to adjust one more thing to set this up correctly so that we can get the final image out of these passes when we compose them together. And that one thing is here in the AOV manager, if we select beauty again, there is the global AOV setting in the light groups section. And this is set to all. So this will output everything as one pass. So all of the lights as one pass. I don't want that because we've got emissive materials in here. I also want to see them as a separate pass. And in order to do that, I can set the global AOV from all to remainder. And now we render these 4 lights as separate passes and everything that is left over as a separate pass then as well. But here's one gotcha. So if I enable the render view here and render here, and now I go to beauty other, that's the new one that has been created now, you can see that it's still all of them. So if you really want to see the remainder pass or the other pass, you can either switch the Redshift render view to bucket mode, or you have to deactivate rendering here. And instead we go to the render settings and make sure that multi-pass rendering is activated. That's great. And now in the Redshift settings, let me set the bucket quality to low. And we're just going to render this for now and see what the passes look like. In order to do that, let's go to the layer tab and let's have a look at the single passes. So this is the one from the right. This is the one from the left. This is BG2. This is BG1. And this is all of the others. And this is important to have that in order to make everything, every pass, one good image in the end. because we want to use 32-bit compositing to bring them all together and make them look like the beauty pass without the separation of the lights. So that's looking great already. I'm going to close the picture viewer, and now let's have a look at the render settings. Now in the render settings, I'm going to lock the ratio and I'm going to set the output to full HD. For now, we just want to output frame 60, and in the save section, I want to save this as a PNG because this is going to be our comparison rendering. I'm going to set this to render / and then I'm going to use the token so that it's using my project name. All right, that's looking good. And now I don't want to use the multipass output. Why is that? Because I want to use the direct output of the AOV manager. And the reason for that is that if I go to the Redshift settings and go to advanced and then to globals, and here in the color management section, you can see that it's rendering in ACES by default. Let me quickly explain ACES. Now, ACES stands for Academy Color Encoding System. And basically what it tries to solve is the following problem: color consistency across devices. So if you have a look at the output devices that you see at the bottom, the problem is due to the amount, no display or screen is showing the same color and also not the color that the colorist created. On the other hand, all of these cameras that you see on top, all of these input devices also come with a different color profile. So it's very hard to get color consistency because all of them are coming with their own look. But ACES tries to solve this by creating one unified color space, which is ACES. And you have two conversion layers. One is the input device transform, where you try to convert everything, every input device's color profile into ACES. Then you do your color correction, and then you convert it to the color profiles of your output devices, like television, a cinema projector, or online video. So how does a 3D rendering fit into this? Whenever you render something, you render in ACES CG. This is also the color space that you use for compositing because it is a linear color space. ACES CC and ACES CCT are log spaces. And then it's basically the same process as here. So what you do is you input some media. This can be texture maps or backplates or video clips. You input device, transform them into ACES CG. You do all your work in here, and then you render it out and comp it and apply the output device transform so you can watch it, for example, on your monitor. But in a more professional pipeline where you have a color correction pass, you can also convert your work from ACES CG to ACES CC or ACES CCT, do the color correction, and then output device transform it to all of the other output devices. That's pretty much the easiest way to explain it. Now, how is that implemented into 3D and compositing programs? This is by using OpenColor.io. So OpenColor.io is a native part of Redshift. And the way it works is that you assign the OpenColor.io config file to the renderer or the compositing program. And this will allow you to convert any color space into ACES and back and so on. So back in Cinema 4D, you can see that Redshift is asking for the OpenColor.io configuration here. And now the view is set to ACES SDR video. Our rendering color space is set to ACES CG. And we have this compensate for view transform. So whenever we render, usually now, then it will automatically bake the output device transform of our display here into the rendering, which is not what we want. So we can either set this one here to raw and untick compensate for view transform, or we use the direct output. And that's what I want to do. So let me go to the AOV manager again. And in here, I'm going to select the beauty. And if I scroll down here, we can disable multipass output. We don't want to use that. And instead enable direct output. So in here, we want to use the data type RGB. The format is going to be OpenEXR because OpenEXR is the format that you have to use if you want to work in ACES. Then we want to render in half float, 16 bits, that's okay. And we're going to use some compression. Let's use DWAB, which is the smallest one. Well, actually, it's really small, but you don't see the compression really in your rendering, so you can really use that one without any problems. Okay, now let's go back to the render settings and let's see if there's something else that we can set up. Well, I want to go back to basic mode and set the bucket quality to medium here. And that's pretty much everything I want to do. And now I'm going to hit render, and after this has been finished, I'm going to import this into After Effects and show you how to set up After Effects to work with ACES. Well, one thing that you see here that might be confusing is that in the layers here, we just have one pass now. But this is because we are rendering out the other passes directly. So they won't show up here in the picture viewer, but they will be rendered to the very same location as where we saved our PNG. And by the way, I'm using an eGPU here. So what I have in there is an AMD Radeon Pro W5700. So that's my rendering setup. So now you can see the output device transform in action, because what we see here right now is an image that is pretty flat because it is rendering in linear, and what you see right now is ACES, and as soon as it finished the rendering it will become darker now, and this is the output transform. But this has only been applied to the PNG that we rendered. In the EXRs that we rendered using the direct output, it is raw, so no output device transform has been applied to the EXRs. Cool, now let's jump into After Effects and play around with this in compositing. Alright, so here we are in After Effects, and here are all of these images that we just rendered. So this is the beauty as a PNG, and then we have all of these different passes here. And as you can see here from the file size, they are not too big because we are using this DWAB compression, which is actually pretty good. So let me select all of these and just throw them into a new comp. I'm going to make the PNG the top layer and make it a little bit bigger here, of course. All right, so in order to work with ACES in After Effects, we have to set the project settings up a little bit. And first of all, we have to click here on the 8 bits per channel button and set up the color. So first of all, our depth has to be 32 bits per channel, and we also need to linearize the working space. Now, if we hit OK, we can work in ACES. All right, let me disable this layer, and everything we need to do with all of these other layers is we need to select them and set their layer blending mode to add, and this will add everything together. But if you have a look at the difference, you can see that it's pretty much the same difference as we just saw in the Cinema 4D picture viewer. So how can we make these EXRs look the same as the PNG in sRGB color space? Let me show you. First of all, we need the OpenColor.io plugin for After Effects, and you can download that for free from the Fnord software blog. And if you search for OCIO After Effects plugin, you will get this, and then you download it for your system, install it, and then the next time you open up After Effects, you will be able to use it. And that's exactly what I want to do now. So the first thing I want to do here is I'm going to create a new adjustment layer, and I call it OCIO. And I place it here right beneath the PNG. So now I'm going to go to the Effects and Presets panel and type in Open to find the OpenColor.io plugin. And that's what I'm going to apply to the OCIO layer that I created. Now, first of all, it's searching for a config file, an OpenColor.io config file. And we're going to use a custom one, which is the one from Redshift. So if you go back to Programs and down to Redshift, on PC, this is in Application Data, Redshift, Data, OCIO, Config, OCIO. And you double click that, and now you have it in here. So now we can either convert this or change the display. We just want to change the display. Our input space is not sRGB, but ACES CG. That's what we rendered out of Cinema 4D using Redshift. But now you can see that this is still not the same because now we still need to convert the color profile. So let me search for a color profile converter. And in here, we just need to set the input profile to sRGB, and then it's gonna be the same. The output profile is still project working space. And now if we switch on and off the Hope PNG, you can see that it's still the same. But now we have all of the advantages of a 32-bit linear workflow. So we can switch off and on lights. We can adjust the exposure of these. So let me maybe go to the other, and let's just go to exposure. This one, let's edit, and let me play with the exposure. So you can see that this is working quite well. All of the reflections are also going to be brighter than before, and so on. Cool. The other thing we can do by using exposures is, let me go to the right light, this one here. We're gonna add an exposure. And what we can do now is we can really adjust the intensity of that light using the exposure, which is great because this is giving us all of the freedom that we need here. For example, we can recolorize everything here. We can make lights flicker and so on simply by keyframing exposures or by adding a hue and saturation. Let's just do that with the background one light. And here we go. Let me just adjust it. And you can see that everything is looking perfect. We don't have to set this up inside of Cinema 4D and Redshift. We can do that in compositing, and we have the full flexibility. So now, unfortunately, with one eye on the clock, I can't comp this completely together, so I'm just going to show you the final result again. So what you can see here is that I desaturated all of the lights a little bit, and also I animated the exposure of those emissive parts in the cubes, and also added some optical glow from Red Giant VFX Suite to the cubes to add even more atmosphere, and here and there a little bit of flickering. All right, before I wrap up, I want to show you two more things. The first one is another example of the techniques that we just learned. So what I created here is just a very similar setup than what you just saw in the presentation, but I just rendered one still and then I animated everything inside of After Effects. So the flickering of the light, the colorization of the light, the fog, everything is animated inside of After Effects. And I also took huge advantage of the ACES workflow here and the linear compositing in 32 bits. And also I not just rendered the light groups for each light, but I also rendered the diffuse channel, the GI, the reflections, refractions, emissive materials, and also the fog separately, so I have full control over everything. So that's also possible using pretty much the same workflow as I just showed you. Great. The last thing I want to talk about is training and certification. As a member of the Maxon training team, I'm interested in telling you what we do. So the first thing is free webinars. If you go to maxon.net/events, you find a bunch of free webinars that you can register for. There is a demystifying post-production webinar each Monday. There are Ask the Trainer sessions twice a month on Thursdays. There is VFX and Chill each Friday. And from time to time, we also offer free hands-on courses, mostly for beginners. And those are usually happening on Wednesdays. Cool. Other than free webinars, we are also doing presentations at events like this one here. And also we do custom training for teams. So if you have some Teams licenses, you might qualify for free training directly from Maxon. And if you want to learn more about that, you can always write to training@maxon.net. Great. So the last thing that is on the list here is certification. So if you are interested in becoming certified, I want to show you what certification types we offer. So first of all, there is the user certification, and then there is a trainer certification. Those are the two types. And as a trainer, you are allowed to offer Maxon certified training and also to certify users. So how can one become certified? First of all, you have to take the certification test. It's actually called the Cinema 4D Basics Comprehensive Certification Test. And if you go for the user certification, you have to achieve a score of 90% and above in order to pass. If you want to become a certified trainer, you have to score 100%. And after you did that, you also have to take the teaching test, because scoring 100% means that you are capable in using the software, but it doesn't tell anything about your teaching capabilities. And this is what we want to see in the teaching test. All right. If you want to learn more about that, then please go to maxon.net/certification or write us to certification@maxon.net. Cool. That's all I have for today. I hope you liked it. See you next time. Stay safe and goodbye, everybody.